Hello everyone, this is KP. So today we are going to build a machine learning model which is basically a regression model. So this regression model will predict the percentage of effect of climate change in the environment. So I'm going to use this regression model to check for the percentage affected of climate change in the environment. First, I have done the basic step, which is the initial step, the importing the basic libraries which are required. So first I have imported the pandas library, which is basically used for the data manipulation and the analysis. And then comes the train test split, which will used to split the data set into the training and testing subsets for the model evaluation. And then we are using the standard scaler. The standard scaler will standardize the features. So this is a pre-processing step to build the model. And here I am using the extreme gradient boosted regressor as it gives me a better result. And then comes the evaluation metrics. So here I have taken a list of 3 evaluation metrics to check for the performance. So after importing the required libraries, then I'm just loading my dataset. So this is a dataset which I have developed my own. It is I have created this dataset. So this dataset contains a set of features to predict this target variable. So today, as we are using regression model, we are checking for the numerical values as the output. It's different. So I'm just classifying here the x and y variables, which is the dependent and independent variables. So these are the features. X contains the features from a list of here to here. So up to here, population density. So these features will be able to predict this percentage affected on the environment. So I'm using this carbon dioxide emissions, deforestation rate, renewable energy uses, and etc. to predict this percentage affected. And then I'm just keeping this y as the target variable. Then comes the standard scaler. So I'm just initializing the standard scaler to the scaler and I'm just switching to the x variable. After this pre-processing step, we are just coming into the basic step, which is just we're just separating this training and testing data. So we are just using this test size as 20%. So we'll be using the 20% of this data to test, and the 80% will go for the training. And we're just using this random state to keep for not change. So after converting the data into training and testing slide, we are just coming to the model implementation step. So the steps. So as I mentioned, I'm using the XGB regressor, which is extreme gradient boost regressor. So I have given a list of parameters here. So which include an estimator. So this an estimator specifies the number of boosting rods for the trees. So I'm just giving it as 100, and then the random state as basic and comes the maximum depth. This will set the maximum depth of each decision tree, controlling the overfitting of the model. And then comes the learning rate. This learning rate is equal to 0.1. So this is going to determine the step size at each iteration to minimize the loss function. And then we are using the subsample as 0.8, which is basically 80% of the training data for building each tree. And then we are just using this column sample by trees. It also specifies that 80% of features for each tree. And then after this, here comes this model fitting. So we just train the model here. So we'll train the XGBoost regression on X train and Y train. So we can see the implementation of model here. So here comes the predictions, and then this line. Here it uses the trained model to predict the target variable. So here the target variable is percentage affected for the test data x test. So after implementing and prediction, we are just going to evaluate the performance of the model using these 3 evaluation metrics. This first one is the mean squared error. So this mean squared error is going to measure the average square difference between the actual and predicted values. So this mean squared error will basically show the average error square difference between the actual and predicted value. So here we have got mean squared error as 0.02, which is basically low, which is showing that the model is about to predict nearly close to the actual data. Also, this mean absolute error measures the average absolute difference between the actual and predicted values. So it will indicate the average size of errors. So then comes the R2 square. This R2 square measures how well the model explains the variance in the target variable. You can see I have got a 99% of the R2 square, which clearly explains the actual performance of my data to the model. So this is the basic implementation steps of a regression model. So you can clearly see all the steps. So I can use this model to check for predicting the amount of percentage affected. So this is all about today. Thank you.